Hello everyone. Today we are going to analyze this frame using cantilever method. This is a two-bay and two-story frame. In this frame there are two lateral point loads, 40 kN in the point G and 24 kN in the point D. In this frame all of the members have the same cross-sectional area. Now let us see the assumptions in the cantilever method. The points of contraflexure in both the vertical and horizontal members are located at the midpoint of each member. The axial stresses in the columns are proportional to their distances from the centroidal axis of the frame. For the center of the columns, let us give names J, K, L, M, N and O. Let us split the frame into two parts. From the center of the columns in the top story, let us take the upper part. So above the center and below the center, we will have the distance 5 by 2. So 2.5 meter. Now let us find the location of center of gravity x bar. We are going to find x bar from the left side. We know that all of the members have the same cross-sectional area. Let us keep the area as A. For the member GM, there is no distance, so the distance is 0. When we multiply area with the distance, we will get 0. For the member HN, the distance from the left side is 4 meter. We have to multiply the distance with the area, so 4a. For the member IO, the distance is 4 plus 8, so 12. We have to multiply the distance 12 with the area, so 12a. In the denominator, we have to add all of the areas. Here there are three areas, so a plus a plus a. 4a plus 12a, we will get 16a. A plus a plus a, we will get 3a. We can eliminate a. 16 upon 3 is 5.33. So x bar is equal to 5.33 meter. We have calculated x bar from the member GM. So the distance between the centroid and GM is 5.33 meter. The distance between the member HN and the centroid is 5.33 minus 4. We will get 1.33 meter. The distance between the centroid and the member IO is 12 minus 5.33. We will get 6.67 meter. Let us keep the vertical force in the point M as Vm, in the point N as Vn, and in the point O as Vo. On the left side of center of gravity, the forces will be in tension. On the right side, the force will be in compression. So, on the left side of center of gravity, the forces Vm and Vn will be acting downwards. On the right side, we have Vo. It will be acting upwards. We know the assumption, the axial stresses in the columns are proportional to their distances from the centroidal axis of the frame. We know that stress is equal to force upon area. We know that all of the members have the same cross-sectional area A. For the member GM, the stress is Bm upon A. For the member HN, it is Bn upon A. And for the member IO, it is Bo upon A. Now let us apply the distances from the centroid. For the member GM, it is 5.33. For the member HN, it is 1.33. And for the member IO, it is 6.67. Here we can eliminate area. Then we will get these. Let us take these two terms. We can take 1.33 on the other side. So it will come in the numerator. 1.33 upon 5.33 is 0.25. So V1 is equal to 0.25 Vm. In the similar way, we can take these two terms and make the expression BO is equal to 1.25 Vm. Now let us take movement about M. In this case, we are moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. BO is acting in the anti-clockwise direction, so it will be positive and the distance is 12 meter. So 12 VO. Bn is acting in the clockwise direction, so it will be negative and the distance is 4. So minus 4 Vn. The load 40 is acting in the clockwise direction, so it will be negative and the distance is 2.5. For VO, we can apply 1.25 Vm. For Vn, we can apply 0.25 Vm. Minus 40 into 2.5, we will get minus 100. We can take 100 on the other side, so it will become positive. When we multiply these two values, we will get these. And when we multiply these two values, we will get these. When we add these two values, we will get 14 Vm. Finally, for Vm, we are getting 7.14 kilonewton. We know that Vn is equal to 0.25 Vm. So we can multiply 0.25 with 7.14. We will get 1.79 kilonewton. Also, we know that VO is equal to 1.25 Vm. When we multiply 1.25 with 7.14, we will get 8.93 kilonewton. In the top story, above the center of the columns, we have calculated the axial forces. Below the center of the columns, the axial forces will be acting in the opposite direction. Now let us split the frame into two parts. From the center of the columns in the bottom story, let us take the top portion. Let us keep the vertical force in the point J as Vj, in the point K as Vk, and in the point L as Vl. In the previous step, we have already calculated x bar, which is equal to 5.33 meter from the left side. We know that on the left side of center of gravity, the forces will be acting downwards, and on the right side, they will be acting upwards. We know that the force in the point N, Bn, should be equal to 0.25 times the force in the point M, Vm. Also, the force in the point O, Vo, should be equal to 1.25 times the force in the point M, Vm. Using these two expressions, we can make expressions for Vk and Vl. Vk should be 0.25 times Vj and Vl should be 1.25 times Vj. Now let us take moment about J. Bl is acting in the anti-clockwise direction, so it will be positive and the distance is 8 plus 4, we will get 12. So 12 Vl. Vk is acting in the clockwise direction, so it will be negative and the distance is 4. So minus 4Vk, the load 40 is acting in the clockwise direction. So it will be negative and the distance is 5 plus 1.25. We will get 6.25. The load 24 is acting in the clockwise direction. So it will be negative and the distance is 1.25. For VL, we can apply 1.25 Vj, and for Vk, we can apply 0.25 Vj. Minus 40 into 6.25, we will get minus 250. Minus 24 into 1.25, we will get minus 30. When we multiply these two, we will get these. And when we multiply these two, we will get these. When we add these two, we will get 14 Vj. When we add these two, we will get minus 280. We can take minus 280 on the other side. It will come as positive. Finally, for Vj, we are getting 20 kilonewton. When we multiply 20 with 0.25, we will get Vk, which is equal to 5 kilonewton. When we multiply 20 with 1.25, we will get VL, which is equal to 25 kilonewton. In the bottom story, above the center of the columns, we have calculated the axial forces. Below the center, they will be acting in the opposite direction. Now, let us find the shear forces in the beams. First, let us find in the member GH. Let us take the joint G. Let us keep the shear force as V. Let us apply the rule sigma V is equal to 0. 7.14 is acting downwards, so that will be negative. V is acting upwards, so that will be positive. Finally, for V, we are getting 7.14 kilonewton. Let us apply that. Let us take the joint I. Let us name the shear force as V. V is acting downwards, so that will be negative. This force is acting upwards, so that will be positive. Finally, for V, we will get 8.93. Let us apply that. Now, let us take the joint D. V is acting upwards, so that will be positive. This force is also acting upwards, so that is also positive. This force is acting downwards, so that will be negative. Finally, for V, we will get 12.86 kilonewton. Let us apply that. Now, let us take the joint F. V is acting downwards, so that will be negative. This force is also acting downwards, so that is also negative. This force is acting upwards, so that will be positive. Finally, for V, we will get 16.07 kilonewton. Let us enter that. Now we are going to find the moments. All of the moments along the beams will be acting in the clockwise direction. You can see that all of the moments along the beams are acting in the clockwise direction. The moments along the columns will be acting in the anti-clockwise direction. You can see that all of the moments along the columns are acting in the anti-clockwise direction. Now we are going to find the moments in the beams. Before that, we have to know in each of the member at the ends, the moments will be same. For example, in the member GH, the moments MGH and MHG will be same, and in the member GD, the moments MGD and MDG will be same. Now let us see how to find the moments. For finding the moments, we can apply the formula WL upon 2. Let us take the member GH. In this member, W is 7.14 and L is 4. Also, we know that MGH and MHG are same. After calculating this, we are getting these two moments 14.28 kilonewton meter. Now let us take the member HI. Here W is 8.93 and L is 8. We know that MHI and MIH will be having the same value. After the calculation, we are getting 35.72 kilonewton meter. Now let us take the member DE. Here W is 12.86 and L is 4. After the calculation, we are getting MDE and MED. Now let us take the member EF. Here W is 16.07 and L is 8. After the calculation, we are getting MEF and MFE. Now let us find the moments in the member GD. G is a joint. It is connecting the members GH and GD. In the joints, the summation of the moments will be 0. That means these two moments will be having the same value, but they will be acting in the opposite directions. So MGD is also 14.28. We know that in a member at both of the ends, the moments will be same. So if MGD is 14.28, MDG also should be equal to 14.28. In the similar way, we can find MIF and MFI. Both of them will be equal to 35.72. To find MHE, we have to add these two moments. After adding, we are getting 50 kilonewton meter. In this case, MEH also should be 50 kilonewton meter. Now let us take the joint D. To find MDA, we have to subtract 14.28 by 25.72. When we do that, we are getting 11.44 kilonewton meter. So MAD also should be 11.44 kilonewton meter. Now let us find MEP. For that, we have to add these two moments and then subtract 50. When we do that, we are getting 40 kilonewton meter. So MBE also 40 kilonewton meter. Now let us take the joint F. To find MCF, we have to subtract this moment by this moment. When we do that, we are getting 28.56. So MFC also should be 28.56. In this analysis, we have calculated all of the moments. We can write them indicating the directions. Now let us find the horizontal shear forces. First, let us find it in the member GD. In the member GD, we have the moments 14.28 and 14.28. We have to add both of them and then divide by the length 5. When we do that, we will get 5.71. Now let us take the member HE. Here we have the moments 50 and 50. We have to add both of them and then divide by the length 5. When we do that, we will get 20. Now let us take the member IF. Here we have these two moments. We have to add both of them and then divide by the length 5. When we do that, we will get 14.29. In the column DA, we have 11.44 and 11.44. We have to add both of them and then divide by the length 2.5. When we do that, we will get 9.15. Here we have to add these two and then divide by 2.5. When we do that, we will get 32. And finally here we have to add these two. So 28.56 plus 28.6, then we have to divide by 2.5, then we will get 22.85. So we have calculated the shear forces in the horizontal and vertical members. We have found the axial forces in the columns. Now let us find the axial forces in the beams. We can use the shear forces in the columns and find the axial forces in the beams. Let us assume the axial forces in the beams are compressive. First, let us find the axial force in the member GH. Let us take the joint G. Let us name the axial force as H. Let us apply the rule sigma H is equal to 0. 40 is acting towards the right side, so that will be positive. 5.71 is acting towards the left side, so that will be negative. The axial force is acting towards the left side, so that is also negative. We can take H on the other side, so it will be positive. Finally, for the axial force, we will get 34.29 kilonewton. Now let us find the axial force in the member HI. Let us take the joint I. Let us name the axial force as H. H is acting towards the right side, so that will be positive. This force is acting towards the left side, so that will be negative. Finally, for H, we will get 14.29 kilonewton. Let us enter that. Now let us take the joint F. H is acting towards the right side, so that will be positive. This force is acting towards the right side, so that is also positive. This force is acting towards the left side, so that will be negative. Finally, for H, we will get 8.56. In the similar way, we can take the joint D and find the axial force 20.56. We have found all of the axial forces. Let us find the vertical reaction in the fixed end A. The axial force is acting upwards, so the reaction should be acting downwards. In the similar way, we can find the reactions in the points B and C. In the fixed end A, we have found the vertical reaction and the movement. Now let us find the horizontal reaction. The shear force 9.15 is acting towards the right side. So HA should be acting towards the left side. In the similar way, we can find HB and HC. Here you can see the bending moment diagram for the columns. Here for the beams. Here you can see the shear force diagram for the beams. Here for the columns. Now we are going to end this session. Thank you for watching this video.